Welcome everybody. Thanks for coming to the Udacity HTML5 programming study group. Really excited to have you all here in San Francisco live and also online on the live stream. Say hello.
Everybody say hello to the internet.
Yeah.
Hello, internet.
Hello, internet.
We'll do this again.
Yeah.
Oh. Well done. You know what? I take that hello back.
Yeah. They weren't there for us when we needed them.
More energy, guys. Welcome everybody. We're here live from San Francisco in the Udacity HTML5 game programming study group. With me is Colt McCandless.
Hello.
From Google, and Sean Bennett,
hey.
course architect at Udacity. And I'm Peter Lubbers, program manager at Google. So we're excited to have you back. This is our third episode in the study group. It's an 8-week study group. If you haven't seen the different episodes, then you can go to Google Developers Live or on the Udacity website under the training course. And you can find information there. A couple of updates. We have made a small change to the contest deadline. So we're running, if you weren't familiar with it, there's still enough time to get into it. We're running a contest in parallel with the course. And a few observant people figured that the contest was actually ending before the course was over. So we didn't like that, or they didn't like it, and we didn't either. Yeah. So we've actually changed it, and it's now going to be done, I think, a week after the course ends. But the details are on the website, so we're sending out an update with that information soon. But stay tuned for that, and you'll have a little bit extra time. So again, not too late to start this contest. It's a great way to sort of figure out if you've understood the concept. What else? Any other announcements, or before we get into it? I think you wanted to say a little bit.
Well, no, we want to talk about the busing.
Oh yeah, right. If you're here in the room, not on the live stream.
Don't worry about this if you're on the live stream.
Take your fine dinner plates with you and put them in the busing station if you wouldn't mind. That would be very much appreciated. By the way, the food courtesy of Google. Again, live stream, sorry, but it was really good tonight.
Yeah, very good.
You should grab some.
On the live stream.
If you haven't had
it,
definitely get some. All right, let's dive right into it. Colt, do you want to talk a little bit about your rants about...
So, show of hands, how many people were here live last week? Okay, fantastic, my people. Okay, put your hands down. Show of hands, how many people who didn't raise their hands before watched last week's stream? Okay, fantastic. All right. So since last week, I got a nice suite, I think is the proper term, of emails from individuals saying, "Why are you so hard on JavaScript? Your bald anger is hurting the web development community, and don't attack us as a people." So I want to take a little bit of time before we get into the awesome set of questions that we have for today, as well as the live interaction we have, and kind of make sure that it's very framed about what JavaScript is and what the web development community is, from a term of a game programmer. So JavaScript is still a pretty new language, and again, this is the perfect time to remind everyone that my opinions are my own and not that of any representative association that I may have some organization with. So JavaScript is a pretty new language, and when you look at when JavaScript was actually created, it was back before the web was today. It's really difficult to think about that when JavaScript was originally created, Pinterest didn't exist, Facebook didn't exist, right? eBay didn't exist, right? I mean, this is back when DHTML was first coming on the stream. I don't even think Google.com existed, right? So this was a language and a specification created for a very different internet than we have today. And so the question that we have to ask ourselves as a web development community, most importantly as engineers, right? Because I think that's the most important part. You're writing code, you need to approach this from an engineer's mentality, is does the current JavaScript setup have all the things it needs to help usher us into the next 20 years of web development? What things are we going to create? What things are we going to expect? What are we going to start doing with new ideas and new patterns? And that's why you start seeing the emergence of things like Dart as a programming language, or TypeScript, or even native client, right? Because people are starting to ask new questions and starting to put new demands on what the web is. JavaScript can do a lot of these things, and I know there's a lot of interest out there. I've seen some articles from Intel talking about adding SIMD to JavaScript, and I think some of the Mozilla guys are trying to figure out how to vectorize that data and things along those lines, and that's fantastic. That's great. If you've ever written a language from scratch, though, hint, how many of you have written a language from scratch? CS 501, maybe? 362, something like that. You actually realize that a lot of the subtle nuances in writing and designing a language have less to do with the functional parameters that are provided to it and more to the aesthetic quality of the mental model that the human brain attaches to it. There was a fantastic research study done about a year and a half ago about mathematics in children. This is a great little diatribe that I'm going to go into real quick. So they took a bunch of students who spoke different languages, all from the same age group, all had semi-similar monetization-based backgrounds, right? So they didn't take like poor people and rich people and compare them. Like, they tried to make sure that everyone was in the same bracket monetarily. And they started doing math quizzes at them. And what they actually found was the individuals, the students who actually spoke Chinese, did about 40% better than any other language. And so they said, well, is this, they tried to drill down, and what they finally came to it was that it wasn't ethnic, it wasn't genetic, it wasn't any of those things. It was actually language-based. Turns out that the human brain can only store a certain amount of data in its short-term memory for a certain amount of time. It's about 8 pieces of data or about 10 seconds worth of short-term memory, right? And so what happens was the Chinese words for the first 10 letters, or the first 10 numbers, are shorter than the Anglo-Saxon representation. So they can actually remember more of the numbers that were in their head to actually do these long mathematical problems. This was a verification that basically we're all running the same hardware. Right? We're all human in some form or another, although I've been called other things by other people, right? So we're all human. The difference is how the language is processing on top of this hardware, right? It's what our software is actually doing. And so a lot of the times when you get these dogmatic individuals who come to the table and say, I will only program on Ruby, let's get Ruby on the web, most of the time it's not because of the functional aspects of Ruby, but because it meets their mental model. So I'm very harsh on JavaScript because I get a lot of dogmatic people coming to me telling me, you shouldn't put C++ on the web, we shouldn't have native code operation on the web, and these are very dogmatic statements, and I always try to attack that with pragmatic statements, right? Like, okay, how many years do you think that'll go until we start asking for more device access in JavaScript, right? How long do you think that's going to go before we start asking for faster prototypes, right? The fact that we already have typed arrays and SIMD support and these things is, you kind of start seeing this language evolution over time. And anytime you start seeing that, you're gonna fork. You're gonna get different languages. You're gonna get different people coming in at different angles. When C# came out, we saw D# come out. We saw D. We saw F come out. F# come out. We never saw C#.
No, we never saw it.
Any musicians in the room? Mark?
C flat maybe.
C flat maybe. I don't know.
Okay.
So anyhow, I want to make sure that it's very clear that when approaching language, you should very much always take the pragmatic approach to it. What tool does it solve, and where does it fit in your toolbox, and what you should do with it? Right? Don't take the dogmatic approach, because otherwise someone's going to hit you with a stick, and most likely they're going to be bald.
Okay. Great. Well, on that note. So if there are any questions in the room here, there's a mic up front, and it's actually 2 microphones, one for the room and one for the live stream. Mm-hmm. So we'll start with a couple of questions from the moderator. And the first one is there any good scaffolding approach to game development? And that was a question from School84 in Sydney.
I'm not entirely sure what this is asking. Yeah. Does anyone have any idea of what this person is asking? I'm not sure what you mean by scaffolding. Go ahead. Could you come up to the mic so that they can hear you on the live stream?
Sorry. I think I can get what he's asking, because I had the same question. Mm-hmm. What he's asking is, when you start a project like a web application project, we take a Django or Ruby on Rails, you have some small commands, like initial set of commands which you run, sets up the directory structure, sets up the initial template, and then sets up everything else for you, so that you go about and fill in the smaller details and your web app is ready. So I think he is pointing out that.
Okay, Yeoman.
Thank you for that answer. I think that's very insightful. This is where one of those areas where my game development background of just throw code at it and solve it later kind of hurts us, right? Don't know the terminology. So yes, we do have a concept of what web developers would call scaffolding in the games industry, and we mostly call these game engines, right? So this is the setup protocol where an engine comes to the table. Mostly it's content driven, right? It comes with a map editor and a scripting prototype and a model editor and some package libraries, binary file access, things along those lines. Unreal 3, Renderware, Gamebryo. These are quintessential types of game engines that you would use for that. So effectively, companies will license these game engines, and then all they have to focus on is the scripting, or at least that's what they're sold. Right. In reality, if any developers in here have ever worked on Unreal 3, you realize that unless you're making a game that's exactly like Gears of War, you have a lot of work under your table to actually make that engine do something differently. And I haven't looked at Unreal 3 in a year and a half or so, so I hope they've changed a lot of that underlying things. But I constantly get emails from people that's like, I spent more time trying to fight the memory model in Unreal 3 today to get it fitting on the Xbox 360. Why did we ever license an engine? Of course, that has pros and cons. You'd have to be pragmatic about it. When you license an engine, you gain lots of leverage, but you also gain lots of new things you have to fix too. So if you're looking for a scaffolding library for game development, I would say look for a game engine. Go through that process.
Any of the game engine.
HTML5, which parameter code would Impact.js be the suitable?
Impact.js I would start with. Ejecta is also from the Impact.js guys. I know there's a
Create.js and Easel.js.
Yeah,
maybe?
Easel.js is Easel.js is kind of a transfer.
Create.js is like an overall package, though. So there's also Create.js, which includes Easel.js, a number of other things, and it includes things like asset loading libraries and a memory model, and something that is a lot closer to ActionScript, I guess, and the kind of model that you would have in a typical Flash environment. So you also have something like that.
That's fair.
Yeah. Okay. Any other build things?
No, I was thinking Yeoman as a general scaffolding. It's definitely made for scaffolding. I've never used it for games, and I don't know. I'm actually be curious to see if anyone here for their own games have used Yeoman. Everyone familiar with Yeoman? Okay, so Yeoman, check it out. That's YEOMAN.io. Yeoman.io. Yeoman. And so you can check that out. It's really great for like scaffolding regular web projects. Gaming, I think you're pretty much going to be stuck pretty quickly. So, and that looks like it answered the question. All right. Okay, so next question from Sebas from Amsterdam, my parents' hometown. Is there any free alternative to Texture Packer?
That's as good.
That looks cool.
That's definitely
So Texture Packer, if you download it, it does come with a trial evaluation period, so you can actually play with it. If you're looking for an alternative to that, you pretty much have to write your own. I've actually got an article. If you hit my blog, mainroach.blogspot.com, there's a nice little articles button that you can click on. It actually takes you to a game dev or an alt game dev day blog I did on creating texture atlases, which is effectively another extension of what we kind of covered in the Udacity course.
Right.
At the bottom of that, there's a whole paragraph dedicated to how to write your own texture packer. With links to source code and examples that people have already done. Effectively, what you're looking for is an algorithm called two-dimensional bin packing. Right now, Texture Packer does some really cool things. Most of it, probably the best part, is how it's UI driven. Right, but if you want a command line version, or you want something else, or if you just don't want to pay for it, there's source code out there already on GitHub and SourceForge and all these other places that you can go grab and play with. You got to play with source though.
Just to follow up to that. What if you know your game's only going to have 20 images and everything, but you really want to use the principles from this course, and you just go into an image editor and you just pack it up you want to. So do you have a diagram that basically says what were the rules for a typical atlas about where the center is and where the what you discussed last week, the trimming.
The trimming,
Okay, and if you did that, you could literally roll your own. Okay, and again, learn something, but you don't necessarily even have to write new code for it.
So there's two questions there from what I hear it. Number one is, if you only have 20 images, is it worth going through the effort to write a full texture packing system? And that's here or there, right? I mean, if you have all the architecture in place and all you have to do is just drag some images into a folder, there's no reason to derivate from that. And hopefully what we provide in the class is enough of an architecture to make it easy for you to work with. That being said, if you want to go and do it all by hand, that's something mostly you automate because artists don't like numbers. They like fire. It's bad.
Okay. So let's go ahead and move over to the live stream. So the moderator, the next question is, could you please use more or any explanatory diagrams? Oh, wait.
Actually.
Oh, is that the wrong one? Okay,
one
I'm
above,
sorry.
yeah.
Yep. Okay, at what point should we have covered enough material to be able to tackle the contest? Does the game have to use grits? Okay. Actually, I would say that you can start writing right now. I mean, you can make up a concept and see what works for you. You could definitely do the design process right now and kind of think through the game flow and how you want the user to experience the game, and then add in more about the actual architecture of the game later. Do you want to add something, Cole?
That's right.
Okay, yeah.
So one of the follow-up here was, does the game have to use grits? And the answer is no. You can really build your own game. It doesn't have to really resemble grits. And in fact, there was a question about even what languages to use. Obviously, we will expect this to be somewhat similar to grits in the end, like a JavaScript game. But people have asked if they can use Dart, which then compiles to JavaScript, and that's totally fine. Forget if that's here tonight, but people are trying that out, and that's not a problem. But in the end, we're looking for a web-based, Canvas game. But there was someone in the audience. Do you mind telling the group a little bit about your game that you're working on?
Oh, yeah.
Maybe on the microphone?
We're putting you on the spot.
Sorry.
Feel our pain.
Yeah. I really like the idea.
Yeah, it was really cool. No dying.
This is not a game yet. This is just an idea. But I was thinking that a lot of times when people are learning to program, they really need to build a muscle memory and learning the syntax. And so I wanted to invent a game called Launch Codes, where you're basically copying code that's already built, and you write a function and it shoots a missile, and you write a if statement and it shoots, you write a loop and it shoots like several, something like that. And it seems pretty simple, and I'm just kind of figuring out how to build it out now.
Yeah.
If anyone wants to help me with that, feel free.
Yeah, exactly. So, right.
So to help you, to help you along with that, definitely check out an open source project on the web called Blocky, B-L-O-C-K-Y. Blocky is sort of an extension of a graphical programming language for, it's kind of an extension of Turtle and Star and a lot of those other ones. But it's all written in JavaScript and HTML5. And so you can actually grab and drop functional visual blocks. But the cool thing is that as it defines a functional piece of data, it also defines what that should output on the other side. So if you're looking for how do you automate your scripting system to go through this stuff, take a look at the Blocky source code, because it's actually going to allow you to say an if statement as a functional paradigm should actually call this code to launch the fire the missiles. Definitely check it out. It's a really cool setup. In fact, one of the games I was working on that I'm not allowed to talk about, we were actually trying to find a solution for a scripting language for designers, because designers come to the table and they don't want to program, they don't like programming, but they need to program because that's part of their job. And so they always want like a dumbed down, watered down version of some programming language, because the programmers, we don't want them in our source code anyway, because they're just going to muck it up, right? So we actually investigated using Blocky for their actual programming language, like allow them to actually do their graph objects and their logic nodes and everything else using that setup on HTML5. So it's pretty full functional. I was actually very happy with it.
That's right. All right. So the next question is, could you please use more or any explanatory diagrams? So I guess the answer would be yes. I think. So I think we've done a pretty good job on some of the lessons to have some introductory diagrams showing what things are about. I guess we could always do a better job. So Carl will definitely look into that for future courses. I mean, everything is pretty much in the pipeline right now, so we can't do that much about it. But we'll say that a couple of people in the larger group of taking this course have done some interesting explanations by way of diagram, and we want to thank you for all of that hard work, because some of those diagrams have been really good, and they somehow should be incorporated back into the course.
Yeah, and I'd also like to say that for any kind of feedback along those lines, like suggestions for better visual feedback, the more explicit and specific you can be, the better for us. I mean, we want to make this better. So all the feedback you can throw at us, I think we are all for.
I had 2 JavaScript specific questions for the homework on Atlas, or the Atlas unit. The first one is declaring the GMAT variable and then assigning this to it. I was wondering, was that done just to make the code more readable, or was that to actually define this for that object? Because the var was actually in the object, so I wasn't quite sure why.
Okay, so this is where this equals GMAP.
Was it this equals GMAP, or was it GMAP equals this?
GMAP is equal to
yeah,
this.
that was because of the, sorry. So the question was during this was in the map loading code.
Yeah. Yes.
Right? Yeah, okay.
Correct.
So the question was in the map loading code, the TED map loading code, there's a line that says var GMAP equals this. Now, if you notice a little bit lower, we actually referenced the GMAP variable inside of a closure.
Okay.
Right? And so basically what happens is we needed to pass that variable to the closure. But unfortunately, the closure didn't accept a parameter to be passed to it. So we kind of took advantage of the gotchas inside of JavaScript by declaring a locally scoped variable that pointed to the this object, which is the entire map parser, such that this closure that occurred sometime in the future outside of the scope of this object would then have access to that entire system. So basically, we couldn't use the this object inside of that closure because when it's executed, it's in a different scope.
I see.
So basically, it was our hack to get around that. Because again, everything in JavaScript's a gotcha, right?
Gotcha. And the second question I have is, I was using a for in statement to loop through the tile sets, and I got, instead of 1, I got 2, and I was wondering, I mean, we talked about this a little bit before the class started, but I was wondering if you guys are familiar enough with the actual object to tell me what was that second thing that I was referring to in the for in statement. So I was looping through the tile sets, so map.tilesets.
This is probably.
So okay. If you were doing you were doing so like 4x in array.
Yeah, but the array had an object in it, and
I think.
Okay, so how for x in array or x in object in JavaScript works is it just goes through that object's prototypes.
Yeah, not
all the prototypes. So it doesn't just go through the elements in the array. It also checks, like, if it has a prototype, has a
dot empty.
Yeah, dot empty or dot length or something like that, then it will actually try to loop through that as well. Okay.
Oh, okay.
So it's not just looping through the elements in the array. Yeah. That's what that might be. Is, it's probably just something that is part of the array object. It's probably not something that is local to our code.
Yeah, we actually,
I would guess.
Maybe. So again, there's a couple things there. First off, for blank in container doesn't actually iterate through the objects; it iterates through the properties. And if you notice in, well, I don't think they have access to core.js.
Yeah, they do.
Oh, they do?
Yeah.
So if you notice in core.js, we actually define a couple array extenders, so like array.remove or array.split or something along those lines, which are effectively like common array operations that you want to do. So like array.remove should have been part of the spec. I don't know why, in someone's infinite wisdom, .remove, the most common concept to an array, didn't actually make it into the spec. Instead, you have to do slice, right? And then you have to have this logic on how many things am I slicing, and so we actually extended inside of core.js where we say array.prototype.remove, and then you give the element index, and then we do the slicing on your behalf.
Yeah,
so chances are, if you're iterating through that array object in a blank for Y container or something like that, you're actually getting the properties of the object and you're seeing this other stuff we added.
Oh, okay, gotcha.
Yeah. now that being said, the blank in our container, I don't even know the proper syntax for this.
Yeah.
So if you say like if name in hash table, that's fine, right? Because it's actually querying whether or not that key element exists inside of that hash table. It's just that looping construct that's actually a little tricky there. And not a lot of, maybe this is something we can fix on web platform docs. Not a lot of people talk about that syntax and how that syntax doesn't do what every other language actually does with that syntax. So I think this is a valuable point.
Yeah, it's definitely one of those JavaScript gotchas that just is really, really painful. Basically, you really shouldn't do the for blank in each or whatever the syntax is on JavaScript objects because it can go painfully, unless you really know what you're doing.
No, I'm going to answer this next one.
Okay.
Peter was just trying to figure out if he has enough battery.
That's right.
Yeah.
Is it not plugged in?
It should be plugged in.
All right. Well, Peter tries to break the internet.
Yeah.
9% left.
We're going to read all the questions before the battery dies. The question is, my HTML5 game runs extremely fast and smooth on my desktop machine, but the game becomes multitude slower on Android tablet, the Nexus 7. Where can I check to see how I can speed up the game? I only have a very few sprites moving around. Fantastic question. Everybody in here is going to fall asleep before I finish answering it. I'm just letting you know that right now. Let's start at the top. So your desktop machine, chances are, has multiple cores, lots of extra VRAM memory, and a very powerful onboard GPU that sucks as much power as it can from that wall socket as you want. Hefty GPUs a couple years ago took about 500 watts. I think the new ones take 700 or some crazy thing. Like you have to have a cooling system and an extra dude running on a treadmill to actually power the thing. Your tablet, on the other hand, does not have that much power being pushed through it, does not have that same amount of GPU or CPU power, megahertz processing strength for it. So first off, you have to come to that concept, is that your desktop machine is multitudes faster and just more powerful and capable at a processing level than is actually in your pocket. Your pocket can do some really cool things, but it can't do everything your desktop can do. So that means things are going to run slower. So now let's talk functionally about why your canvas rasterization is actually running slower on these devices. So the weird thing about this is that no one in this question is actually talking about what browser they're running. So if you're using stock Android browser, unfortunately the canvas rasterization is really slow. So all of our code that we talk about here is all about canvas. It's not about modifying DOM elements, because that's just insane in a box. So we actually do proper rendering. If you're using it on the stock Android browser, that's not going to be fast. That was never optimized to be fast during that process. Now, if you're using Chrome Stable, as of a couple days ago, which I think was 24, 25, I think. The canvas rendering was actually pretty good, but still not as good as it should have been. I think Chrome Beta actually has a lot of increases there. Basically, it came down to the engineers making sure that their code paths underneath the hood are actually optimized in the proper patterns to take advantage of the fact that they're running on lower powered hardware. You'll also see in my blog series, as well as the Udacity course, we talk about the fact of additional overhead that comes from a draw call. So in computer graphics, we have this concept that you do a lot of crazy stuff, and you actually call primitive.draw, right? And primitive.draw, believe it or not, actually has a ton of CPU overhead associated with it, because that CPU.draw has to go down into the APIs and do a lot of type checking and initialization and pass some memory around, maybe make some copies, cook some souffle, change outfits once or twice before it's ready to go to the ball. And then what happens is when all that's finally done, then it actually issues the command down to the driver level of your operating system, which then, upon its own good and well time, will actually issue the thing out to the bus and actually get to the graphics hardware. So what you're looking at is stacks of overhead here from a single draw call. Canvas is no different, right? So if your Canvas, or the browser that you're using, actually has software accelerated Canvas, that means it's doing all of that stuff in software rasterization. It's not actually using the GPU to accelerate anything. This is one of the reasons the stock Android browser is actually so slow. It's all software rendering. If you notice in the latest Chrome, everything is actually GPU accelerated for canvas rendering, which actually means they're going through the right primitives in the Skia library to actually have the GPU draw all this stuff. But there's still a significant amount of overhead for those draw calls. The next article I'm doing in my blog series, so the first one was how to load TEDs, the second one was how to accelerate your canvas rendering using Grit's prototype. The next one was actually about ping pong canvases. And the interesting thing about that is we actually use this old school technique that John Carmack and those guys kind of found out about using dirty rectangles to invalidate certain parts of the screen, and then just shifting the entire canvas over like 8 pixels at a time. So basically, you'd like shift the previous frame over 8 pixels, and then you'd invalidate where the new sprites were, and then you would only draw those locations. And because you were only updating like 1/16 of the entire buffer, things ran faster. So the new article that I'm writing is how to use this technique in HTML5. The problem is on the Nexus 7, it still runs dog slow, about 20 to 23 frames a second. And the problem there is nothing to do with the GPU. It's actually humming along pretty well. It's all the overhead in our internal layer to actually handle all those draw calls. Because if you guys know, the standard Grits map actually does about 200 draw calls a frame if you're not actually using all these tiling techniques. So this is a very complex question right here. So even though you may have a few sprites running around, you might be on the stock Android browser, which is going to be running slower, or you may be in one of the later ones, but not actually, still doing a lot of draw calls for those single sprites. You may not have proper culling enabled or something along those lines, because if you're using a little dude and you have a full background, it might not be doing it. So yeah, how many people fell asleep on that one? I saw 2. 3.
Yeah.
Mad props.
Yeah.
I'd be asleep right now. This is late for me.
Yeah.
This is I start my day at 5 a.m.
The other part, where can I check? How do we measure?
Oh, yeah.
Yes, that's
Where
the
can I
second
check
part.
Yeah.
to see how I can speed
So
up?
if you're doing development for Chrome on Android, Google for a term on basically it's an article by Boris Smus, S-M-U-S, and he actually talks about Android remote debugging. And so effectively what you do is you download the Android development tools, and so it's basically just a copy, it doesn't mess with your registry or anything. And then you can actually go to a command line and run an ADB command. So basically there's an executable in the directory called ADB. You run ADB with a little command line argument that actually will forward what's going on your Android in your Chrome browser to your desktop machine. So this is where it gets really cool. Basically on your desktop you browse to localhost 9222. And then it'll show you what tabs are open on your Android. And you can actually click on one, and it'll open DevTools. And then DevTools works exactly as it would on your desktop. You can put breakpoints in the code, you can change the CSS, you can actually run a tracing tool. And so basically, all of the standard techniques that you would do to optimize your performance on the desktop, you can now do the same thing on Chrome for Android. So I would definitely say start there. If you want to dig deeper from that, for those of you daring souls who like getting into the belly of the beast, or you realize that DevTools and some of the other about tracing stuff doesn't give you the full, like, hey, I have one function that's running slow and I don't know why. You can actually check out a new library that I actually just uploaded to my GitHub account. GitHub? What am I, Canadian?
Yeah.
GitHub account. Sorry, github.com/mainroach, and it's under the sandbox section. It's called Needle.js. Needle is an inline invasive profiler. And so basically what this means is you litter your code with begin and end blocks, and then what Needle will do is actually measure the time deltas in this scoped environment and then spit it out in a form at a very, very fine grain that you can load into about tracing or something else and actually see where all of your time is going. About tracing and DevTools do a great job of getting you close to this stuff, but I haven't actually been able to get data closer than the functional level. And for the DevTool team that's watching this, I apologize at my ignorance if there's some better way to do it. But for those of you guys who really want to dive deep and drill down, definitely check out Needle.js on my GitHub account. Any other statement? Like where else? More on DevTools stuff?
No, I think
you've pretty cool covered it.
So maybe say the URL again?
Yeah, so that's on my GitHub. That's going to be github.com/mainroach, one word. I'm sure someone's going to come up to me afterwards and go, where did you get your nickname Mainroach? And I'm going to tell you, as I've told the hundreds of people before you, that answer requires beer.
Okay. Okay, next question. Can we use any frameworks besides Box2D in the game contest? Yeah.
Yes.
I mean, yeah, use whatever you think works for you, really. I mean, we're going to be looking at basically the end results.
Exactly.
Right?
Exactly.
So,
yeah.
And if you want to use other web languages like Dart or other languages that compile down to JavaScript, if you want to use other frameworks, Box2D, if you want to use a game engine framework, sure, make a cool game. That's really the goal.
Yep. Great. Next question from T Creative from Germany. Can we use some of the graphics and sounds of grids for the contest? Would love to use some of this art on my game idea.
It's all open source.
It's all
open source?
So it's all open source, and the assets are all licensed under the Apache 2 library.
Yeah.
So yeah, I'll say that into the microphone. It's all open source, and all of the art and sound assets that aren't already contributed to Creative Commons or whatever are under the Apache 2 library. So I am not legal counsel, nor will I ever be legal counsel. I quite frankly don't know what Apache 2 means at a business definition level, but it's expected that you do if you use it. So.
Okay, next question. Why has XHR get changed from its original definition? This is because it was making, and this is your fault. This is because it was making very liberal use of this.
Ah, that's right.
Yeah,
that's right.
And because of the way this works, this isn't actually the keyword this. This is so hard to talk about.
The whole language is a gotcha.
Yeah, the whole language is a gotcha. JavaScript, the whole language is a gotcha.
We need to come up with a new meta language that describes the concepts of the language that we're writing and programming in.
Yeah, yeah. Instead of just copying other languages.
We'll call it widget def.
Yeah,
or something like that.
Yeah. So this in languages that games are typically written in. does not mean what this means in JavaScript. This is, in regular languages, basically a call to the object context, like the encompassing object. And in JavaScript, it's actually a call to the calling object. Is that correct? I'm not the expert on JavaScript gotchas, but so if I am, say, running a grading script over your code and calling your code to test it, and it uses this, then instead of this being, say, the XHR get encompassing object or anything like that, or this being, say, the tiled map class, this will actually be the grading framework, the testing framework I'm using, like Mocha or Chai. So it's trying to get, Mocha dot, color or something like that. And it doesn't know what that is because it doesn't exist. So that's why the definition has changed, because it made very, very liberal use of this.
My fault. I never said I was a good programmer. You people just keep assuming this.
Okay.
This was mine.
Yep.
So I'm gonna preface this that I love this question. I absolutely love this question. I think it's pronounced as Jorg from Austria. If you have lots of entities in your game and you're processing interactions between them, like collision or even non-location-based events, this is an awesome question. The easy approach is O to the n squared. So effectively, you loop through all of the items and then you check if that item is touching all of the other items, right? So that's big O notation. What ways of optimization are there? Can you recommend some resources about that? The reason that this is an awesome question is because for a number of years, I actually used a variant of this question as an interview question for any job I worked at, which is fantastic. So let's rephrase this question in a different way. And this is kind of a nice little exercise for everyone out there playing the game at home. So let's put it this another way. If you have a data file, and in this data file, you've got 1,000,000 points, 2D points, XY positions, right? And you read this data file into memory, and I ask you, hey, here's a point in space. Give me the closest point from your original array to this new input point, right? The step would be, oh, well, let's iterate over everything and see if it's close. And that's going to end up in this sort of similar pattern. And then you say, OK, well, hey, now we've got 20 million. What are you supposed to do then? And then you start thinking about, like, oh, wow, well, I guess we go into bucketing, right? I'm a firm believer that there's really only 4 major principles in computer programming for optimizing something. It's like caching, bucketing, threading, and culling, right? And so bucketing. So hey, what if we actually divide our 2-dimensional space into 64 pixels by 64 pixels, right? And then when you query a point, or basically when all the points are read in, you say, hey, you're in this 64 pixel by 64 pixel block. And then when the input point comes in, you only have to choose what block, right? So you're basically transforming space there. And you go, OK, cool. So what's the next step past that? What if all of the 1,000,000 points are in this lower left-hand corner and the input point's way up there? Obviously, you're not going to find the closest point to this input point. So what's the next step past that? Then you actually have to start looking at new data structures to sort of represent your input in memory, right? You have to start looking at ABT trees, BST trees, binary space partition, red-black trees,
octrees.
Octree.
No, that's
Octrees are still going to give you a static-based definition structure. You want KD trees are a fantastic algorithm out there too. Effectively, you got to go back to the source. You have to start looking at the way that the data structure algorithm is going to represent your data in memory. So that's how you fix something like this. You can't just rely on arrays. You have to actually go back to the Donald Knuth data structure concept. Go research binary trees and linked lists and bucketized linked lists and every other data structure out there. And that's the only way you make this stuff any faster. Great question. If you're listening, ask more questions, dude. You're my new favorite person on the internet. True story.
I have a follow-up. So would you ever go about writing that?
Yeah, sorry.
Yeah.
You should just stay at the mic.
Yeah, just stay there.
Favorite person in this.
A great answer. So, but my question is, would we ever go to that details when writing our games? Because most often, those are like interview questions, and then at some point in time we do handle them for some prototypes. But when you are building games or writing applications, those are already solved for us in terms of libraries.
Massively incorrect. So I'm gonna sorry. How many MMO players are in here? World of Warcraft, EverQuest, Free Realms, stuff like that. Club Penguin. Club Penguin?
What is Club Penguin?
It's a cool game. You should try it.
You don't know?
Habbo Hotel, maybe?
Yeah.
Anybody? Habbo Hotel? No 4chaners in the room? Okay. So you're playing an MMO, right? So a massive multiplayer online thing, and you're playing a cleric. Okay, a cleric is a healer class, and you cast a spell, and this spell says heal everyone in a 10-foot radius to me. Now this is a massive multiplayer game. You have 10 million other people on the same server that you can see. Which people do you heal? Right. So there's not a library that comes with this, right? So I mean,
so that's the business representation, or that's the player representation. What I'm saying is, so you are a node, you are X and Y, and there will be a library to map 500 points. So map 500 points common to X and Y. So I will just use that library and then get all the 500 points and see the collision.
If that library fits into your code base, if that library fits in your memory processing patterns, if that library is fast enough, if that library runs on the Xbox 360 where your client happens to be doing processing, if that library is written in Python because you're actually doing your processing on a server, or if that library is actually written in JavaScript. Sooner or later, if you want performant code, you got to write it. Yeah.
Okay.
Also, so if you do actually want a library for this, there's one that I recommend. It's called the Approximate Nearest Neighbor Library, ANN. Just look for ANN library. It's fantastic. I first found it when doing a lot of research on Hugh Hop's stuff, who was doing texture synthesis work. It's fantastic. Very cool.
Oh yeah, ANN was a great answer. I had forgotten about it. But similar to ANN, I presume, of course, there will be like because any good way to develop application is like develop smaller portions of it, like libraries, factor them out, and then use them so that anyone else can use it.
Yeah, absolutely. Yeah.
So, like ANN-like libraries, something more?
Something like that. But I'm actually going to completely knock your Jenga tower over again. In that, if you're using ANN, that's fantastic in a development environment. But if you're actually using it in production, there's a lot of problems because the code that you actually ship to your consumer is never just the library. So, for instance, how does ANN track its memory?
I don't know.
Yeah, exactly, right? Well, if you're running on the Xbox 360, you damn well better know, because you only have 512 megs of RAM. And if ANN, for some reason, in its algorithmic wisdom, decides to use 700 megs, you're out of luck. And you actually got to go back in the depths, right? More importantly, what if ANN is leaking memory? Right, so now you have to actually go in your C++ code and overload the new operator, and then you see that for some reason this stuff, I mean, so basically you're going to have to go into the depths, the belly of the beast sooner or later. There's very little off-the-shelf software that really, like, hardcore engineer game developers respect in terms of like, yes, this does its job and it does it on every platform. SpeedTree is one of the fantastic examples of that. Those guys run an amazing simulation on tons of hardware across everywhere, and it runs really, really fast too. I really like the Substance editor from Algorithmic, whatever. I've never been able to pronounce their name, but they also have a great setup there too. So Scaleform, maybe, right? So there's everything's cut. Yeah.
Okay.
Yeah, great follow up though. Yeah.
Oh, sorry.
We need to tape more mics together.
Yeah. The solution is more mics. We already have 2 there.
It's just turtles all the way
Yeah,
down.
it's turtles everywhere. There we go.
Thank you. Yes, thanks. So way back there was this idea of drawing something into a frame buffer and then that was hidden and then switching it. And then in regular JavaScript, I've done this where you draw into a div whose CSS is not displayed, and then when you're finished, then you switch its CSS so it is displayed. So if you're drawing into a canvas, is there something in HTML5 canvas that is equivalent of that?
Yes, if I understand your question correctly. So to take a step back, so what we covered in the map rendering class was that each 64 pixel by 64 pixel part of your map may have also depth, right? So there may be 10 images stacked on that single 64 by 64 pixel space in your larger map, right? Because the artist may have come in with layers. And so you're basically doing 10 draw calls for that vertical column, so to speak, right? So the way we accelerated that was we effectively created off-screen canvas buffers, which are basically just a canvas object that isn't attached to the DOM. And we render, so we render the first 20 by 20 pixel setup into one canvas, and the next canvas, and the next canvas. And then when we go back to draw later, we actually handle the canvases as objects rather than the individual loose sprites. And then the Canvas API actually allows you in the draw image command to pass a Canvas object to it. So that's how we get into that situation. So you can toggle it. So if you're basically, we're drawing a canvas to a canvas, which I think is analogous to what you're mentioning about actually creating a div and then showing it a little bit later. The draw image API is how you would display a pre-computed atlas onto the canvas.
I see. So it's more like it's sort of nested rather than toggling back and forth between two canvases.
Right. Yeah. Yeah. So when you, and Peter probably has a lot of great visibility in this. I'm a horrible HTML5 programmer. You know, when you add an item to the DOM, it's kind of on visible by default unless you set it that way. When you create an off-screen canvas, it's not visible to the canvas at all. The only way to actually get data back on the canvas is with the draw image or draw APIs in some form.
Yeah.
So,
You don't actually need to create the canvas as part of the DOM. Basically, you can just create the canvas element, and
you don't touch it.
you don't even have to worry about it.
And I think you can write another canvas, an image, and I believe even a video to that canvas. So you can even take another canvas, write it to that canvas.
Do we want to go over the video question from last time?
Yeah,
we didn't actually get to it, but it's a really good question.
But does that answer your question?
Yeah.
Okay. Actually, that reminded us of another question from last week's moderator. Basically, why are we using, I'm just paraphrasing here, why are we using animation instead of, why don't we use video for the animations? Colt had a great answer. Probably now is a good time to
that leads into it pretty well.
Right. Sure. So great question. I love all these great questions. They're fantastic. So the question was, why are we not using video for animations? A couple things here. Number one, it actually starts with the content creation pipeline, right? So for an artist to actually go through and create frames of a video versus just loose sprites in Adobe Photoshop, we're talking night and day difference here. It's easier for an artist to just make these single frames and then pop them through there. Number two is compression, right? So typical video codecs actually need good compression to properly display itself. And so what's going to happen is we're going to have this little 128 by 128 sprite animation that's actually going to have compressed artifacts in it to actually get it onto the web in a performant manner. And number three is transparency. Videos don't actually support transparent pixels that allow us to blend with the background frame. Now we can change some CSS elements and actually make the entire thing blend with the background frame, but there's not really a setup unless there's a separate processing engine that says, hey, make this pink color actually transparent and don't draw that to the screen. To my knowledge, there's no API for that in HTML5. So we actually could not use a video, like functionally use a video to play our animations for that one concept alone.
All right, cool. Send her the trimmed image. Okay. This is definitely you.
Yes, okay. We don't want to answer it. Give it to the bald guy. Why do we need to calculate the center of the trimmed image using a different formula? Why can't we use the same old formula to calculate that? Great question. This is one of the places where I really have to applaud the Udacity community. There's been a lot of confusion about sprite trimming, and if you go check out the forums on that quiz, there's tons of great answers and tons of great information there. In fact, they did better diagrams than we did, quite frankly. So mad props to those guys. If you go there and check it out. The short answer to this, I think it's already answered there, but I'll cover it yet again, is that although the sprite.frame.w actually stores the dimensions of the sprite, it doesn't take into account the fact that the sprite may be offset. Right? So if you always assume that the trimming factor is always trimming towards the center, then all you have to do is divide by width and height. But if you assume that the artist might have put this data down in the lower left-hand corner, then dividing by width and height won't actually give you the true center of the sprite. You also have to take into account translational offset due to the trimming. And that's why the trimming code is pretty complex. You can't just divide.
Sure. Okay. Next question is, from what I've seen, this course seems to be more of an exploration of grits rather than actually teaching HTML5's features specific to game programming. Is that the case, and if so, why? So I really like this question, actually. Colt is more of a fan of the game programming and optimization questions.
That's your favorite person on the internet?
Yeah, this is my favorite person on the internet right now. So personally, I think that one of the best ways to learn is to build something. And another great way to learn is to see how someone else built something. Read through their code. See how they thought through the processes that you're thinking through at the same time. And in that vein, I think that this as an exploration of grits and seeing how we approach this and also coding it up yourself, as we're going along, while also building your own game is a great way to learn how to build a game for the internet, because it is a very non-trivial problem. So I think this combination of seeing our code and working through our code and thinking about your own projects and your own games and your own desire to build something awesome is really why we're doing this the way we're doing it, and why we are teaching class the way we are.
And I have a follow-up to that too.
Yeah, I think we all have a follow-up
yeah,
to that.
and I'd actually like to challenge this question too, because I think basically what we're trying to do with this course is teach you HTML5 canvas rendering, and we're trying to do it through the lens of game development. And for someone to come to the table and say, all we're doing is talking about grits, I think is actually a success in that metric, because you don't understand that you're actually learning John Resing's object-oriented prototype setup, and you're actually learning things like XHR get and how to fetch data from the internet and how to draw things to the screen, and you're going to learn about asset loading and package management, and you're going to learn about all these other things that HTML5 does, but it's all in the context of a game. And so if someone is thinking that all we're doing is using grits, and they're not learning anything about HTML5, yet they have this functioning game at the end of it, I think, in my opinion, that's a success. We've actually taught someone HTML5 just with the right context.
Yeah, just to add to that, so I used to do a lot of HTML5 training, and when we first started out with that, we really just took like the different APIs and examples of each API, but they were not really connected. And as a result, there wasn't very little learning going on, because I mean, all you learned was canvas and then stroke a line to the canvas and see what's happening. Here you see a lot of different things moving together. That's actually much more a real life case. In fact, when we started the course, we looked at what shall we, like the idea was an HTML5 course, but what to use as an example. And then right away there was the game idea, and I was like, well, then in that case we may as well use a game that is much bigger than just build it from scratch.
An actual game.
Yeah, it's actually something that Colt had been working on with 4 or 5 other people for many months.
5 other Googlers.
So, yeah, so I think that really makes sense. I would agree to some extent, though, that there are a couple of things in there that are pretty deep into the game code. I mean, that's what you're going to get to build this particular use case. And I think, like we said before, we're also thinking of already a next part of this course, which would be a server-side course, and then a mobile extension on top of that. I think, again, the gaming tends to take any platform and really push the limits, so that's also a reason to do this. And I think you'll find, even in the, if we don't have any dates or anything for the follow-up classes yet, but there's a lot of other concepts, things like WebSockets and XML HTTP requests, all of those things. And I think it starts making a lot of sense. Units that we haven't aired yet, or they haven't launched yet, we'll talk about web audio. That's very relevant. I mean, that's pure HTML5, I would say. So anyway, so that's just a little bit extra.
Yeah. We should pass this one to.
Shout out. Colt's dad.
The question is, I downloaded Grits during Google I/O last year, and yesterday I logged in, but that was as far as I could go. When is Grits going to run again by Dad in Las Vegas? First off, hi, Dad. Thanks for watching my course. Appreciate your support. That's actually my father, ladies and gentlemen. A big round of applause for my father. Logging in to give me shit. This is awesome. So when we launched, I gotta answer it like straight face now. So when we launched Grits last year, we were actually doing it sort of ninja stealth mode and actually running our compute server side on Google Compute Engine. But it actually wasn't announced by the time Grits launched, so we weren't actually allowed to talk about it. In fact, if you watch my Google I/O talk, at the very end of it, someone actually asked me a question and says, "Hey, where are you running your Node.js server?" And I'm like, good question. I just moved on. Because we hadn't actually announced Google Compute Engine yet at that time, so it was kind of funny. Google Compute Engine, they're doing their stuff under the hood. I don't actually think it's open for public yet, and so we've been kind of having to keep asking them for access again, because they'll kind of go through and say, all right, well, we gotta unwhitelist everybody so we can get back to our work, and unwhitelist everybody, and so I have to keep putting in a request to be like, please give me access again, and then I gotta go fix up everything so it'll run. And these guys are still doing a great job creating this amazing cloud solution for the future of web computing, and I'm unfortunately chasing the dragon's tail on that one. Also, chasing the dragon's tail, fun story about my dad. Great shout out to my father. When I was actually growing up, he and I actually used to use video games as sort of the way we bonded. And I actually like to attribute the entirety of my career to those times that my father and I used to sit around playing video games for ungodly amounts of hours. More importantly, when I actually finally decided that I wanted to make video games for a living, my father and my mother were the few people that said, yes, whatever you need, let's go buy you as many books as you want, let's spend as many hours as we can talking about it. I actually remember he took us, we all took a trip to the mountains one time, we were camping, and I actually printed out pages and pages and pages of code because we didn't actually have a computer with us. And I spent the entire camping trip in the RV under a light highlighting code and trying to understand stuff. And as a father, that was one of the coolest things that I thought he ever did, is he dragged me out to this fishing trip and let me sit in there and program all day. So you know, I hope that everyone in here has a similar story about how your parents kind of influenced your dreams and brought you to where you are in your life, because my father was one of the key influences in that. So thanks for giving me shit, Dad.
Okay.
Follow up that.
Yeah. I'm not. Okay, it's time to go home. How far can we go in copying concepts from another game without getting sued? What are the things to pay attention to? In moving from FPS to tower defense, I will copy a single shot feature where one bullet kills the enemy.
We're not there.
Yeah.
We are not lawyers.
Yeah.
I think we're going to move on.
we have no legal advice that we can give you.
Nor can we.
Yeah.
It's being live streamed to over 50,000 people.
Yeah, so no.
All right. I found the YouTube transcripts helpful, but they haven't been released for Unit 2. Will they be forthcoming? Or is it something I can do myself on YouTube? Is there actually?
Yeah, so the transcripts, if those ones aren't released yet on the wiki, I was under the impression they were, so I will get those done as soon as I can, probably tomorrow. So, yeah.
Awesome.
No?
Is there We've got a couple more questions. If there's any more questions from the room,
you might
jump up.
want
It's
to jump on
about
it.
three
we've
minutes left or so.
Yeah. Ask the hard questions now.
Yeah.
Is there a place where we can get more background on the image compression and the calculating of the positions in the compressed files? So I'm addicted to image compression as an algorithm. I think it's one of the most amazing things as a computer programmer that you can dive into. It's kind of like my version of heroin for programming. It's just you want more in lower files. But I don't think he's actually talking about image compression here. I think this is actually talking about the trimming concepts in compressing out unused space inside of Texture Packer. If you want to know more about packing images into larger images, definitely check out bin packing as an algorithm. Google for that term and check out my articles on my blog and my alt dev blog posts there as well. There's a lot of good resources there.
Will the study group videos be available for download? Yeah, they should be.
So let me take this one. So the study group videos are, as you may have noticed, on the Udacity YouTube channel. So this is being streamed live on the Udacity YouTube channel and sort of overlaid also on Google Developers Live. So if you're not familiar with Google Developers Live, check it out. It's developer.google.com/live. And there you'll find, so that's sort of our TV channel, right? So we have a Chrome channel, if you will, where we broadcast lots of episodes of, for example, The Breakpoint with Paul Irish and Adi Osmani. Chrome apps shows, we have like one every week. Office Hours for several technologies. We have Ilya Grigorik doing lots of his Make the Web Fast shows. Really awesome stuff.
Amazing.
Check that out.
Yeah.
Some incredible content that we make available there for free. And you'll also find these Udacity study groups sort of simulcast there. I mean, it's basically just a pointer to the Udacity video stream. So yes, you can download them there. Not sure why you would do that. Maybe just watch them on YouTube. But yes, you can download them.
Well, I think probably one of the reasons is a lot of our students are in low bandwidth areas where it's a lot harder to stream things continuously. So it's easier just to start a download and come back in a week.
Yep.
So, so that's actually true. Yeah. Okay. In an earlier study group, we were entreated to contact you directly via an email address. It wasn't visible in the video, and I can't seem to find it. Could you make it available? Okay, so if you are in the course, then you should have been receiving fairly regular emails. If you respond to that email, or if you check what email address that comes from, it is sean@udacity.com. All of those emails, and whenever you respond, come back to me. So if you have any questions or comments or feedback or anything like that, please send me an email. I get a torrent of them after every one of those emails.
We actually call his facial hair the feedback beard. True story.
Sure, yeah. And on that note,
oh, God damn it.
One more.
This is actually you have to answer this one.
Okay.
So
That's right.
Not a question, but I was promised awesomeness, so I want more story time and more blooper reel. Or as my 2-year-old grandson says, I want my Google. Thank you again, Dad. So first off, quick question for the people in the room. How many people find story time and the blooper reel stuff? You guys like that? Is it good? Round of applause. You guys enjoy it? More of it? Some people. No one cares. Awesome.
Yeah.
So then I leave this to you.
Okay. So yeah, we have a fair amount of content in terms of blooper reels. A little bit. Hours of Colt stuck in a room, tiny little room with no light on, talking to himself. It's fairly entertaining. Yeah, we can totally get some more of that up. The main problem is bandwidth for our amazing video team, specifically Calvin who he climbs a lot. He tolerated all of us, really, for this entire time. And yeah, if we can get some time for him to do that, I think it would be a lot of fun. We should definitely put some more blooper reels up.
If you want that, email Calvin who at.
Yeah. No, don't do that. Okay. Okay.
All right. So there's really one more question.
Yeah, one more question.
So
here.
let's take that.
Yeah.
And then we'll wrap it up.
Oh, I think we.
Oh, clients pack consume
There you go,
respawn
Mike.
bonus. How can we track items
Well,
per?
yeah. So great stuff. Keep blogging, Colt. And can you remind people again where they can find your blog? It's not.
Yeah. So my blog is at mainroach.blogspot.com. I try to put corollary stuff in there. If you actually go there now, I've actually got a series of how to do faster canvas rendering based upon what we've been talking about the Udacity course, and there's going to be more stuff there as the course unfolds, sort of this other channel of, oh, by the way, I forgot to talk about this.
Yeah.
And the final question. So
Down.
this one.
Can you please explain how the items such as the energy canister are updated for the server so all the clients see the pack consumed and then respawn? Bonus, how we could track the items per Google account?
Do we have time to cover this? I mean, I can do it briefly, but do we want to go?
Does anyone need to leave right now? Because this could go a bit.
We've got 3 minutes.
Yeah.
Okay.
Hurry up.
So we will cover this in great detail in the next Grits class, if the next Grits class manifests itself. But I will go into it very quickly right now. So effectively what occurs is that we have a Node.js instance that's running on the server. Now the reason we chose Node.js is so we can actually share the server code and the client-side code next to each other. The server code is actually running a lockstep simulation with each of the clients. However, the clients are actually doing predictive physics. So the server is a definitive server, right? So effectively what happens is all the clients are doing their little input. The input gets sent up to the server, and then the server will tell the client, hey, this is where you move to. So the user hits the arrow key. That gets sent up to the server. The server says, it'll process a physics frame and say, hey, you moved 5 foot, right? Then that 5 foot location is actually sent back down to the client. And then the client says, cool, move 5 foot. Of course, this is going to cause problems because you've got latency, you've got lag, you've got ping, and you don't want to see your little robot actually jitter its way around the environment. Because of this, we actually use client-side prediction, which means the client will say, you hit the up arrow, it'll send its command up to the server, and then the client will predict where he's supposed to be going and actually start moving you in that direction and render you in those positions until he gets a ping back from the server that says the accurate corrected position. And then what we'll do is we'll use those two pieces of data, the client-side predicted model and the accurate server-side model, and we'll slowly converge them over a number of frames. So what happens is you'll constantly be getting out of sync with what the server is doing, but you don't notice it because you're actually only off by a little bit each frame. So how things like the energy canister play into this is that, again, you move to a location, and physics box 2D will actually say you have an intersection. But again, the server and the client both have to agree that this intersection has occurred. So what happens is you move to a location, and we have a client-side only response to... Hello? Oh, cool. Been doing that. Maybe it's my forehead. We have a client-side only response to the fact that you actually touched your energy canister. But then later on, that's actually validated by the server. And the server will say, hey, this energy canister was touched. Send these commands out to all of the P2P players that are actually in the environment. So there's this really beautiful ballet of how messages are sent back and forth from the client and the server, what the code does as a response to that. And it's really complex and it's really crazy. And the guy who wrote most of that architecture was actually named Craig Tiller. He's an engineer working at Google now, but in his former life, he was actually a server programmer at Blizzard working on World of Warcraft. And before that, he was actually a server programmer working at a great company like Crytek, entirely focusing, again, on server programming. So Craig is an amazing beast of an engineer. He's also a really, really funny guy. We love hanging out with him. And there's some really, if you go trouncing through the Grit's code base, you'll see lots of just nuggets of wisdom that you're like, how does this work and why is it running so amazingly? And that's all Craig Tiller. So mad props to that guy. And again, we'll cover this in the next class if you get all of your friends to sign up for this one.
All right.
All right, so with that, we're going to wrap it up. So a couple of final announcements. Again, the contest for the course has been extended. Information is up on the website. There's definitely still time to start that if you haven't. And a couple of people here in the room, like Dan, has formed like a little study group, a little contest group within the study group together.
You guys, yeah.
And so that's great. And if you're looking for people to team up with, especially here in San Francisco, there's probably a good amount of people that want to team up. If you win this contest, and we have several prizes, we have some really cool stuff. If you didn't know this, one of the prizes is a ticket to Google I/O. They're pretty hard to get. The other one is a cameo appearance in one of the future Udacity training courses, which is also a lot of fun.
Yeah.
All expense paid trip up to a certain amount of dollars.
Yeah.
And then we have a bunch of hardware, Chromebooks. Maybe we'll throw in a game of this versus that.
Oh God.
Just for fun.
Programmer joke.
Yeah, programmer joke.
So we'll do that. Next week's study group here in San Francisco, same room, same time, same great food. And with that, I think we'll turn it over. The video will be available in recorded form shortly after this course. And I'd like to thank you.
Thank you guys for your
Thanks
attention.
for coming.
Appreciate it.
Yeah,
Thank you.
Thank you. Okay. Yeah. Good. All right.